So today's webinar, Assessing Sustainability for Agriculture and Urban Forest. Our presenters today, I'm going to turn it over to Guy Robertson, who's our National Program Leader for Sustainability Assessment, and he'll introduce the other speakers today. Guy?
Okay, I have the talk button on. Can you all hear me?
Yes, we hear you quite well. Thank you.
All right, very good. Yeah, I don't know why my title is on there and nobody else's. I apologize for that. But yeah, I am the National Program Leader for Sustainability Assessment with the Forest Service Research and Development Arm. And I'll go ahead and start here. Okay, the title of this presentation is Assessing the Sustainability of Agriculture and Urban Forests in the United States. And this is in response to the report we just released. It's been a number of years in the making, and I'm very happy that we were able to get it out. My main job in the Washington office now is to do a sustainability assessment, and primarily that has to do with the National Report on Sustainable Forests. And the reason why I'm telling you this will be clear in a slide or two. So, but first off, let me give some credits to the people that were engaged in this project. Myself and Andy Mason served as editors for the report. And for authors, we have Greg Lickness, Andy Lister, David Nowak, Charles Perry, Steve Rasmussen, Michelle Schoenberger, and Chris Woodall. Steve is with the Nebraska Forest Service, and everyone else is with U.S. Forest Service R&D. And also many thanks, of course, to our numerous reviewers and the people who helped with the layout and printing. They did an excellent job, particularly on the cover photo. I was quite impressed with the way they put that together. Okay, but before we start, I did want to ask you all why you're here. This will give us an idea of your main interests. And so the first question is, our first one is A, I'm mainly interested in urban forestry. The second one would be those interested in agroforestry and trees on agricultural land. And then next is I'm interested in landscape scale management and the unifying role of trees across different land uses. It's a mouthful and it's somewhat ambiguous, but it's this idea of trying to look at landscape in a more unified fashion. And then finally, I don't know, quit asking me questions. Maybe I'm here just for the credits. But without any further ado, let's see what the poll says. All right, very good. I see many people are interested in the unifying role of trees across different land uses and sort of the landscape scale management question. It will be interesting as we proceed because you'll find out, and we'll talk about this more later, is that the actual database for having a unified conception of what's going on in urban and agricultural forests is still very much in development, and we're still challenged. I think you'll find that we're still binned up into different disciplines, and that'll be clear as we go forward. Okay, first off, I want to begin with the context and rationale for this report. This is a companion report to the National Report on Sustainable Forests, the first one of which was released in 2003. The next one was released in 2011, the 2010 report, and we expect the next one in 2017. These reports provide a comprehensive forest sustainability assessment for conventional forests in the United States. And by conventional forests, we mean lands meeting FIA definitions of forest. And we'll talk about that in a slide or two. This report, the current report, however, focuses on what could be thought of as the forests left out of the national report, i.e. those that do not conform with FIA forest definitions. Okay, continuing with the rationale for the report, the reason why we put this report together was, first off and foremost, a need to better understand a vast and valuable resource, and at times I think underappreciated in terms of its scale and importance to the nation at large. It's also to help lay the groundwork for a comprehensive wall-to-wall inventory of trees and forests in the United States. And that will hopefully facilitate landscape-scale ecosystem management spanning jurisdictions and land use types. And it will help unify our approach to measuring and understanding trees and forests in the United States, wherever they occur. Okay, now a little bit about definitions. What are agricultural and urban forests? We're taking a very broad definition here. We're calling it forest and trees located on urban, peri-urban, or what I found out from Google, can also be called urban lands, and agricultural areas not meeting the FIA definition of forest. That not meeting the FIA definition of forest is perhaps the most important part of our definition. So once again, it's the forest left out. In the national report on what we're terming conventional forests, once again those that meet the FIA definition, the FIA, in other words, Forest Inventory and Analysis data, provides the backbone of the entire report. If you don't have a forest inventory, you really don't have a sustainability assessment. And so what we're looking at right now with agriculture and urban forests is the lack of that sort of forest inventory. And so our question right now as we're going through this report is what can we do to better bolster that sort of database so we can start doing the same sorts of assessments for forests on agriculture and urban lands. Okay, now getting to the potential scale of the resource, it is quite vast actually. We're looking at, in terms of urban land area, 60 million acres, but 138 million acres if community lands are included. This means land that might be outside of strictly defined urban areas, but include small towns, villages, and perhaps ex-urban type developments and things like that. Tree cover on these lands is currently estimated at approximately 35%. And then on the cropland, pasture, and range, we have over 1 billion acres. But unfortunately, tree cover estimates are not available for these lands. Now, if we extended the 35% to those lands, of course, we'd be talking about 350 million acres, which would be about 50% of the total forest use land in the United States, of 651 million acres. Now, mind you, these total land use estimates are coming from the Economic Research Service of the USDA, and they're not necessarily comparable to FIA numbers or some of the other numbers you might see. Also, I just recently checked the 2007 update of the numbers for these. They're quite comparable, but there has been some changes. Unfortunately, there was not a published report that I could cite for this report. But really, the numbers haven't changed that much. We've seen a little bit of a reduction in cropland and also in range, and a slight increase in forest lands and other uses as well. Some of that might be definitional changes also. Okay, the importance of agriculture and urban forests. In general, the benefits are similar to conventional forests, but also they have many unique benefits. So similar to conventional forests in terms of biodiversity conservation, aesthetics, many other things, and also, as I said, many unique benefits. And these benefits are oftentimes greater than might be implied by the area alone, and this is because of proximity to human populations and to agricultural production systems with concomitant ecosystem services, aesthetic benefits, spiritual benefits, a lot of the different ways in which we find forests to be beneficial to human beings. And then finally, it also serves a role in unifying landscapes and maintaining ecosystem integrity. In this sense, wildlife migration, aesthetics, riparian systems, etc. And I'd add that as we think about more and more about forests in these areas and forests in general, we are finding more and more reasons to think that they benefit human beings in different ways. In some ways, our understandings, our let's say, the catalog of benefits are limited currently by understandings in our imagination. The more we think about it, oftentimes the more we find. Okay, but at the same time that we're looking at trying to put agricultural and urban forests and trees on the same page as, for example, FIA forests and conventional forests, we're running into a lot of measurement of challenges associated with these forests. The first being spatial configuration and fragmentation. And for example, street or garden trees, linear forests, and heterogeneous distribution across the landscape. The challenge here is that our general measures for like forest area and a lot of the measures we derive from that are based on per acre or acre measures for extent. And a lot of those measures don't work very well in terms of the linear forest or individual trees. So trying to develop measures that can be comparable between these different types and configurations and conventional forests is certainly a challenge.
Hey, Guy, this is
Likewise,
Bob.
we have fragmented ownership. Yep.
Several people are still saying
Bob.
they're having a very hard time hearing you. Is there any chance you can move your microphone a bit closer to you?
Yeah, sorry, I was not paying attention to the chat box. Is this better?
Jim, do you hear that better? Or, no. So, Guy, let's pause for a minute and have you call in using the telephone.
Okay, I will do so. Have you got the number, Bob?
So, Guy, you see the little telephone up there next to the audio
yes,
setup wizard? Go ahead and click on that, and that will show you the telephone numbers to call in. And
okay, I'm dialing in right now.
Sorry about that, folks. We were hoping his audio was going well enough. He'll be back on here in a second.
Please enter your conference number followed by the pound key.
My apologies. Yeah, actually, we have these headsets that we use for our soft phone, and oftentimes they don't seem to work out too well. Sometimes they do. I hope this is clear.
Yep, everybody's indicating it's much better.
All right. Thank you very much, and sorry about that. I'll just go ahead and continue from where I stopped, and I'm talking about the challenges associated with agricultural and urban forest measurement. And the first part was the spatial configuration and fragmentation. And the basic challenge here is trying to get measures that are comparable with our standard forest measurements of acres and things like that when we're talking about trees and forests that really have a very different configuration than what we're used to when we're talking about conventional forests. There's also the problem of fragmented ownership. This means small parcel size and various diverse ownership types. So, you're looking at an urban landscape, for example, and you'll see trees and gardens owned by individual people. There's parks, there's streets, there's all kinds of different ownerships. And that means that oftentimes it might be difficult to garner cohesive or consistent information from these various groups. And then the third one is the lack of forest management focus. Oftentimes, at least traditionally on our conventional forest land, we had large forest owners who actually do have an interest in forestry, and through that management focus they developed statistics that we can draw upon. And that also extends to socioeconomic statistics. For example, employment numbers for people engaged in forestry and forest products related areas, things like that. We don't have the same sorts of cohesive measures for the social and economic areas as well. All right, so the current state of knowledge about agriculture and urban forests, and this is really one of the key questions we address in the report and one of the main conclusions we draw. It's not a very exciting conclusion, but it's still an important one. And the first conclusion is the data needed to describe agricultural and urban forests at the national level is virtually non-existent. We do have extensive research and experience related to specific times or places, and this includes one-off studies and spatially restricted inventories. But these are not commensurate with the information on conventional forests that we have at national scale, primarily that from our forest inventory. And at the same time, also the ancillary data, and for example, employment numbers are not developed or identified, and indeed it's kind of difficult to try to think about what the employment numbers associated with these forests would actually be. and how we would draw distinctions and put that together. But, and here's the second conclusion also, the situation is improving. We have increased recognition of the value of trees and forests in different settings, and this includes green infrastructure and ecosystem services. The quotes are not meant to be scare quotes. They're really meant to just say that these are complex concepts and that various people will have different definitions of what they mean. Remote sensing combined with on-the-ground plot sampling are yielding cost-effective options for inventory, and this is being shown especially in the urban area, where urban forest cover estimates have already been developed, and the extension of urban FIA will actually, if someone could mute your phone, I'm getting a lot of feedback here. It might just be me. Urban forest cover and extension of urban FIA will allow for national level monitoring and reporting of urban forests. A similar approach is needed for agricultural lands, however, and in that area we do not have much information at all, especially that is aggregatable at the national level. And once again, social and economic variables will continue to present challenges. And just some examples. One of this is an iTree Eco project. I don't know if Dave is going to talk to this today, David Nowak. But this is a kind of a participatory sampling program for urban areas. It's based on a common set of variables that people can use their iPhones to report out on. And ideally, these numbers will be aggregatable at higher scales or at least comparable across these areas. And then also here are some of our urban FIA and other activities that are going to be talked about. The urban FIA are on the West Coast and some of these purple states right here. And then the states outlined in yellow are the Great Plains inventory, which will be talked about by Michelle later on in the presentation. Okay, and then finally I wanted to put a short note on comprehensive forest sustainability assessments using CNI. I don't have much time, and I don't want to dwell too much on this, but I do want to emphasize that the idea behind a lot of these processes and the assessments that we do is to try to look at forests comprehensively. And that means looking at ecological, social, and economic indicators. And the approach we use is based on the Montreal process criterion indicators. There's nothing special about it, and there's nothing magical about it. It's just a flexible we use it in a flexible application and also a flexible interpretation of the data that it presents. And it becomes a touchstone for development of a rational and explicit monitoring professional. I've done a lot of data on my own reference. But it's broadly applicable to agriculture and urban forests with substantial modifications. Not a straitjacket to be locked ourselves into. It's just an example of potential measures that would be considered in some sort of comprehensive sustainability assessment. Then outlined for the rest of the webinar, Michelle Schoenberger at the USDA National Agroforestry Center will be talking about agricultural forest resources. And then David Nowak, who is with the Forest Service Inventory. And then inventory options will be addressed by Charles Perry and Greg Leckness, who are also with Forest Service Inventory and Analysis. The red text on the inventory options is not there on purpose. That was a mistake that I made, actually. And there it is. So, without further ado, actually, well, now we're pretty much out of time for questions. And besides, I want to turn it over to some of the experts. I'm the generalist here. And so we'll go directly into Michelle's presentation, I think. So without further ado, here's Michelle Schoenberger with the U.S. National Agroforestry Center.
Hello, everyone. Hopefully you can hear me. My mic might be better, but my voice is not today, so please let me know. This next section focuses on the agricultural forest resources, so we're going down on the farm. A more correct term for these resources really is agricultural non-forest tree resources, or ANTS for short, sort of a close cousin to the Ents for those of you that have read The Lord of the Rings. As Guy already alluded to, the role of trees in supporting agricultural production and the health and vitality of the rural landscapes has long been recognized. In fact, one of the most massive tree programs, the deliberate planting of trees in support of agriculture and agricultural lands, was the Prairie State Forestry Project in the Great Plains. In response to that Dust Bowl during the 1930s, over 200 million trees planted in fragmented linear configurations called windbreaks were planted. They were put in place to protect the soils and crops from North Dakota down to Texas, and it was a very important tool in support of agriculture then. But even more so today, these resources have become more important as we've become more aware of the many services they can provide us. But to understand this value, we need to first be aware of the many demands and challenges producer and agricultural lands are now facing. We all look to these lands to not only meet our needs for food, feed, fiber, but also biofuels and pharmaceuticals, as well as we ask them to provide critical wildlife habitat, protection of the air, soil, and water resources, and it's really that overall health and vitality of the lands we live in. We'll all need more of these services to meet a growing population, and this will need to be accomplished under the future and large uncertainties of shifting weather and climate we're facing. So these agricultural non-forest tree resources are playing and actually can play even bigger roles in helping agriculture meet these production, these natural resource, and these resiliency goals.
Not that I know of.
Whoops. Well, these ants can be simply defined as, Greg said, as trees on agricultural lands that generally do not meet that conventional definition of forest. And again, that's why they're not included in forest and tree-related inventories. This lack of inclusion is mainly due to their small size, canopy cover, and width, as can be readily seen in these pictures. With regards to ant resources, there are two main categories. Those that are deliberately established and managed, and naturally occurring trees. Let's start with the naturally occurring trees. These are the ones that occur as isolated trees, isolated and dispersed woody draws, riparian forests, and even trees that naturally get established along fence rows. Now, while these are not intentionally established, these naturally occurring trees still provide many ecosystem services that we benefit from: carbon sequestration, wildlife habitat. We also need to recognize that some of these naturally occurring non-forest tree resources may be in phases that adversely impact services we seek from the land, and therefore it's still important to get information because that requires a different management. And a good example of that is eastern red cedar expansion in the plains. Now, the other category of ants is the deliberately managed and planted trees, and this is the area that I work in. These are the tree resources that have been intentionally established in specific locations with specific species and specific arrangements to achieve specific functions and are closely associated with crop and forage production. As a group, these are referred to as agroforestry. There are 5 main categories of agroforestry: alley cropping, civil pasture, forest farming, riparian forest buffers, and windbreaks. And the growing 6th category, that's really special applications. These are agroforestry technologies adapted to address emerging issues such as biofeedstock production and stormwater management. More information on agroforestry can be found at, and please leave out the www, just go with nac.unl.edu. Now, agroforestry provides a wide variety of services in support of agricultural operations and lands, and it's important to note that a single agroforestry planting, if you actually properly design and manage that planting, you can actually get several of those benefits listed up there simultaneously. And it's because of this multifunctionality that agroforestry, this agricultural non-forest tree resource, is considered a win-win option for providing some of those key climate change adaptation and mitigation services that are going to be needed to enhance the food security and resiliency of U.S. agricultural lands and operations. Because of these benefits, there are numerous USDA programs in place, such as EQIP and CRP, as well as other state and local programs that provide support for technical and financial assistance. This assistance is targeted to the establishment and management of these plantings. And again, more information is available at nec.unl.edu. So inventory, providing the what's for the whys. Simply put, wise management is essential to sustain and enhance the values associated with agricultural resources, and wise management in turn requires good information. Well, what exactly is that information that we need? Well, we need to know the specific resource type and extent, the condition of the resource from which we then estimate the contribution, and hopefully then put a dollar value on it. And by having this information over time, we can see if and how these resources, and therefore their services, so we really need to tie it back to services, might be changing. Extremely critical information if we're going to make those wise decisions regarding actions, be those in the field or, just as importantly, in policy and program directions. And this information is what we get from continuous inventory. As Guy mentioned, agricultural non-forest tree resources have not been explicitly included in either of our two national inventories, the Forest Inventory Analysis and the National Resource Inventories. So we lack any of this information. And here's just a quick example to illustrate why this is an issue. Carbon sequestration, very important for meeting national greenhouse gas mitigation goals. By putting this field, just 3 to 5% of the field into a windbreak for purposes other than carbon, the carbon sequestered in the field would almost be doubled compared to just conversion to no-till alone. So we can estimate this carbon for a planting, but this lack of inventory information keeps us from estimating any type of accurate national contribution. And as such, this contribution and potential future contributions are therefore not included in such decision-informing things as the National U.S. Greenhouse Gas Inventory. Now, Guy talked about the Great Plains Tree and Forest Invasives Initiative, or GPI for short. This provides us with a good model for understanding the kind of data development efforts that could be applied at this national level. This was limited to just the 4 Northern Plains states. And the GPI was a one-time only study that collected wall-to-wall inventory. The purpose was to provide insight regarding these non-forest trees in that region, especially in regards to vulnerability of these trees to such threats as emerald ash borer. The goal, to characterize these tree resources using FIA-compatible methods so that data can be integrated with the FIA collected data. Now, I'm not able to go into the particulars of the study or all the data, but I wanted to illustrate the value of having this information. Looking at just the all states data at the far right, the blue column representing non-forestry area, and the red representing forest land areas defined by FIA, we immediately see that FIA is missing about 1/2 the forest or really tree-related resources in this region. What else can we pull out of this GPI data? Well, if you're like me working in agroforestry, we can actually dig out information specific about the windbreak extent in each of these states. The extent of each type of windbreak practice, in this case, either a field windbreak, farmstead, or livestock windbreak, and very importantly, the condition then of each of these windbreak types. Invaluable information which the later speakers will talk about. Having this information, we can then generate and therefore importantly communicate the value of this resource. This was done by the Nebraska Forest Service. Now, 2 things to note. The estimate is $102 million per year, a significant value, but this does not reflect the full benefits derived from both the field windbreaks and farmstead windbreaks. And secondly, the GPI inventory identified that most of these windbreaks have an ash component, letting us know that the sustainability of these plantings and therefore the sustainability of their services are highly vulnerable to emerald ash borer. And as of this year, we've got it here in Nebraska. So again, it's that information to guide wise management. Now, the problem with GPI, it was a snapshot. It was for 2009 only, and we know that things are ever changing. Comparing 2009 and 2012 tree cover, we already see we're losing this resource. This is due to expansion of irrigation, and this is most likely due to the high corn prices we're seeing. So this begs the question now in 2016, what's happened since? Are we still losing these resources? How much? How fast? What's the impact? And the big question, what's happening with this resource nationally? So bottom line, that consistent, continuous inventory information is critical if we're going to be able to effectively and sustainably manage for the valuable resources these resources provide us. So now let's go beyond the fence line of the farm, because agricultural non-forest tree services and their benefits cannot be fenced in. They just don't stay down on the farm, and these effects are far-reaching beyond their boundaries, especially for important things like water quality benefits. Further, they can be strategically assembled across the entire rural and urban continuum to meet these larger scale type objectives. A good example is addressing water quality to tackle hypoxia in the Gulf and in the Chesapeake Bay region. Now a little bit closer and smaller scale to everybody, what about stormwater management? For many urban areas in the Midwest and elsewhere, that planting area is approximately 20 to 30% urban, and that other 70 to 80% is agriculture. And that's a great place for ants in the toolbox. Now, agroforestry technologies in both the Kansas City MARC project and Green Topeka study were recognized as a highly valuable multifunctional tool in helping to address stormwater management, that green engineering, while simultaneously being able to provide other valued services, that recreation, the wildlife corridors, even phytoremediation and biofeedstock. Well, I think I worked my way right into my next speaker's backyard, urban forest, so I'll quit now. And did I leave any time for questions?
You have, so if there's any questions of Michelle, this would be time to add them into the chat window so that we can go through them and hopefully get them answered for you. So we'll give them a second here or two. So folks, as we move forward today in the presentation, as you do get questions, feel free to type them into the chat window so that when we get to the end of the presenter, we'll be able to go through them. The first question that has come in is from David, and are any of these windbreaks targeted along riparian corridors?
A riparian corridor can act as a windbreak. And you might put a windbreak that occurs at that interface of water in the upland lands. So it depends on what that primary function is of the planting going in. So like I said, they can be multifunctional windbreaks, essentially modify microclimate. That's its primary purpose. Riparian corridors or riparian buffers would be there for water quality. So either one of those would be providing those multiple services of water quality, modifying microclimate. Does that answer your question? Oh, good.
Okay, any other questions for Michelle before we move on to the next presentation? So do forestry or other ecosystem objectives commonly come into play in locating windbreaks?
I would say yes. And I think they should increasingly come into the planning aspect because the multifunctionalities of these systems are being recognized. For the farmer, the landowner, the producer, the primary thing will be increasing his return. So the primary objective will always be income, a crop yield, livestock protection. But those other forestry and ecosystem objectives, so for instance, if you're looking for a travel corridor, that windbreak might be located and designed such to connect travel corridors and habitat. You might include different designs into those systems. These are excellent systems to incorporate pollinator resource needs, nesting, forage and food, as well as even pesticide drift. So you can incorporate all of these into the design. Those would be secondary designs, but again, you're accomplishing all of these in one planting. And I just saw the one, it mentioned that the planning aspect is very important and getting the landowner's objectives up front is critical. Exactly. So essentially when we go out there, you want to find out what that landowner wants. And then really what you're discussing with them is, are they aware of what else can be attained in the design of the system? And generally those other objectives can be incorporated with very little more investment and input. Well, I think I'm almost out of time.
So did you answer the question on how do you attract farmers to transition to agroforestry?
Oh, I did not get that one. That one was slipped right past me. What was that again?
So the question is, how do you attract farmers to transition to agroforestry?
Well, at this point, I'm actually going to give my personal opinion because I think those type of decisions is very much a one-on-one deal. And the reality is you're not going to go from conventional agriculture to agroforestry. I think it's a transitional type enterprise. Essentially, you introduce a farmer into some type of tree-based or woody-based practice that meets some of their needs, and it's at a scale that they can get used to that and find out how he or she then can capitalize on creating agroforestry systems on their farm. Obviously, incentive programs help tremendously with that experimentation. And then you just have early adopters. If you can get them sort of adopting these, that peer pressure is an excellent way to influence people's opinions with regards to agroforestry. And by the way, agroforestry is not a silver bullet. It's only a silver buckshot. So if it makes sense, if it's the right reason, the right tree, the right place, then it should be adopted. Otherwise, farmers really shouldn't. That might be heresy, so maybe you need to get me off here, Bob.
So there appears to be one more question from Stephen Kuhn. Minnesota recently passed a waterway buffering zone requirement. Is there any government program designed to plant these areas with shrubs or trees?
Definitely, and what I will say is that they passed the legislation, and I think there's many efforts right now ongoing up in Minnesota that's going to talk about the planning and design criteria with this. So they sort of got the cart a little bit above the horse on this one, and I do know there's actually going to be a meeting in September where different people are going to be brought together up there in Minneapolis, I think, to discuss exactly this. Things such as targeting, things such as species selection, things as prioritizing where they should be put in. So I think that what's happening in Minnesota is going to be very, very exciting to see, not only that it's going to be put in place, but how it unfolds.
Okay, thank you. And with that, we are just a few seconds from the end of your time. So,
great.
All right, I guess that puts me up. This is Dave Nowak, and I have the section on urban forests. So to start with this, first of all, good afternoon, everybody. This section is on, let me define urban forest. Is pretty much so we know what we're all talking about is, we define urban forest as all the trees within an urban area. So whether you're talking downtown of the city, parks, street trees, all the trees within the urban system are classified as the urban forest. So logically, the next question becomes, what is urban? So in the process of trying to assess urban forest nationwide, we went to the U.S. Census. And there are definitions, two types of definitions we'll be talking about in this presentation. One is urban land, which is pretty much areas of the United States is classified by the census as about 500 people per square mile. And in this graphic, you can see those are the orange areas. And they're also within the census definitions areas called communities. And those are the ones that are outlined in the black there. And as you can see, not all communities are urban. Not all urban areas fall within communities. So a community is basically a political entity. So I live in the city of Syracuse. There's a political boundary. That is the community boundary, or the urban, the community boundary. And urban land are the areas within New York State or within the area that have at least 500 people per square mile. So what we're looking at times, most of this presentation is going to be about urban land, which is in the orange part of this graphic, is areas with 500 people per square mile. So what do we know about urbanization? And why is it important? Well, one of the issues we have to deal with is that urbanization is growing across the nation. So myself and Eric Greenfield in my office have been looking at census definitions of urban and trying to project that forward. So what I'm going to show you in the next few slides is how much urban land do we have in this country. And this is, as you can see in this graphic, this is by county. So in the graphic, counties that are white have less than 1% of the county classified as urban. Again, those are areas with 500 people per square mile. And as we move to the dark red areas around New York, Atlanta, Chicago, and some other cities, that's 80% of the county land classified as urban. And as you can see in this graphic, in 1990, 2.5% of the lower 48 states was classified as urban land. And what I'm going to do is flip through in motion as you can watch how urban land expands in this country. So in 1990, it was 2.5%. In 2000, it jumped to 3.1%. And in 2010, currently, it was classified as 3.6%. And what we did, Eric and I, is we looked at the patterns over the last 20 years, and using those same patterns, we projected forward for the next 50 years. So what I'm going to show you is if the same patterns of development hold over the last 20 years into the future, what our country is going to look like over the next 50 years in terms of areas classified as urban. So you can see here we are again, 2010 at 3.6%. And as we move forward, 2020 we'll go to 4.4%, 2030 5.2%, 2040 6.3%, 2050 7.4%, and 2060 8.7%. And what's important to notice on this graphic as you're watching the colors change is where are they becoming darker red? What you're not seeing is North Dakota and Wyoming jumping out, the rural areas or the more agricultural areas. What is happening is the New York City metropolitan, Boston, Washington corridors becoming darker, Florida's becoming darker, areas around Atlanta. And what this is showing, which makes sense, is that areas that are urbanized are going to become more urbanized. And the reason for that is we have the infrastructure in place. We're not starting new cities in the middle of nowhere. We're expanding outward from the infrastructure that we already have, which means the areas around the urbanized areas today are going to become more urbanized into the future. And this is the issue we're going to have to deal with because most of our population, 85%, lives within these urban areas. It's going to jump up to 90% in the future. So we're going to have high concentrations of people consuming more of a land base within the future years. So our projections going forward from 2010 to 2060 is urban land is going to consume about 2 million acres on average of rural land. I hope I said that right. Urban land is going to consume about 2 million acres of rural land per year over the next 50 years on average. We're going to jump from about 68 million acres of urban land currently, or 3.6, to about 163 million acres, 8.7. That increase in the consumption of the rural land base by the urban land base is an increase greater than the size of Montana. And the urban population will jump from about 85% urban to about 90% urban. That's assuming that the patterns of the last 20 years hold. Again, anything can change this in the future. It could go up, it could go down, but based on the pattern of the last 20 years, we're headed for more and more urban land, particularly around the areas that are already urbanized. So if we want to assess sustainability of this, one issue we have to deal with is that urban land is going to expand. So areas that are agriculture, areas that are forest are going to convert to urban and become urban forests. Areas that are already urban forests are going to change and provide values to society. So what's important of understanding is structure, because structure leads to functions or the benefits, which leads to the value to society. What we manage, or what we need to understand, first of all, is structure. How many trees do we have? Where are they located? From that, we can estimate the functions and the value. What we tend to manipulate as managers, we don't manipulate functions and value. We try to influence functions and value by manipulating structure. So if we want to manipulate structure, we have to know what the structure is as a starting point. It's very difficult to manage a grocery store if you don't know what's on your shelf. It's very difficult to manage urban forest if you don't know what you have in the forest. So this becomes critical in terms of assessing the resource. So what do we know about structure? One thing we know is that about 80% of the U.S. urban land is within forested areas, and this becomes very important in the future. Most of the people in the United States live within forested regions. Why is that? Most likely, why are forests there? The forests exist in our country because there's adequate water. Most people need water, so we tend to put our cities within areas of adequate water, so we tend to live within the forest canopy. What do we know about those forests? Eric and I have been spending a lot of time assessing tree cover. And these are numbers from approximately 2005, and you can see on average in urban areas of the United States, tree cover averages about 35%. In rural lands, it averages about 34%. So actually, urban areas have a slightly higher urban tree cover than rural lands. We have about 20 million acres of tree cover and about 4 billion trees within that resource base of that 3.6%. And it varies by state. As you can see, cities that are developed within forested regions have higher tree cover because they have ample water. They have a natural sea source. There is a lot of regeneration going on in cities. You can see those are the top 10 or so states on top. Connecticut, Massachusetts, New Hampshire. Within the urban areas, about 2/3 of the city or urban areas are covered by trees. And as we move to the drier western states, Idaho, down through Wyoming, there you can see tree coverage down around 10%. So where you are within the system, whether you're in forested regions, grassland regions, or desert regions, has a huge influence on the amount of urban forest that you have. Average in forested regions, cities average about 40% tree cover, grasslands about 20% tree cover, deserts around 10% tree cover. But in the deserts, we have to import water in order to sustain the canopy. So cover is one of the easiest metrics to assess. We can do this from aerial photographs, we can do this from satellites, so cover is easy, but we need to know more about cover. We need to get down to the number of trees and the species compositions and the risks to the forest, the more detailed measurements about size and species composition. So we've been measuring urban forests probably for about 30 years within the Forest Service, starting back in the late 80s with the city of Oakland. And through time, this has evolved to a model called iTree Eco, or the iTree Modeling Suite. And you can see in the upper left graphic where people have been assessing urban forests. What iTree allows you to do is put your own data in. You can sample your area, you can inventory. It'll assess back the structure and various ecosystem services and values. It's a globally based tool, but it involves people collecting the data themselves. Just recently, starting in 2014, forest inventory and analysis have picked up monitoring cities within our country. And you can see in the lower right-hand graphic, the ones with the yellow dots have started collecting data in 2014 to 2016. There is a report out for Austin. We're just finishing a report for Houston. The other reports will be coming out later. It's on a panel basis, which means, except for Austin and Houston, that they're collecting about 1/7 to 1/10 of the city per year. So we won't be able to produce a report until they get enough panels in to measure the whole city systems. And you can see other cities are online in 2017. So we have two possible processes, and there's differences between the two, but there's a lot of similarities. iTree and FIA are merging together to help people to analyze urban forests. FIA provides consistent quality data and a long-term monitoring by partnering with the cities. iTree is up to the user, so iTree cannot necessarily assure the quality of the data. It's up to the user to pick those to assure the quality, because it's just a computer program, garbage in, garbage out type system, but it will help set up the plots and people collect the data. Whether there's quality assurance, it's up to the users of that data. But we have been using various data that we've collected from the Forest Service using iTree and other places, other cities, to try and assess forest cover nationally. There is some overlap between traditional forest inventory and urban areas. About 14% of all trees in urban areas are already picked up in forest inventories because there are forested stands within urban boundaries. But there's a big gap of non-FIA or non-forested areas that need to be picked up also. But we're getting there. The technology is there through FIA and through iTree to do that. And that's critical measurements that we need to have. And why do we need to have that? Because if we know the structure of the forest, it can then lead to understanding the benefits of the forest and quantifying the benefits. There are three benefits here that I think most people understand in terms of trying to get people involved in understanding why we should have trees in cities and what are the benefits. And people tend to understand shade and cool air. They tend to understand aesthetics, and they tend to understand wildlife because they're tangible. They can sense, touch, see, or feel them. However, there are many other benefits that people don't necessarily know that are coming from the urban forest. Things such as altering building energy use and emissions from power plants by cooling the environment. Various products that can be sold from urban areas, particularly using waste wood into waste wood streams that make products. A lot of implications for human health in terms of related urban forests affecting water quality, air quality, ultraviolet radiation, physiological changes to human bodies when they see vegetation. There's a whole huge impact because most people are concentrated in urban areas, the impact of the forest is significant in those areas because the forest is right where the people are and does affect the quality of their lives along with human health. Most of the effects are positive, some are negative, and it's trying to find that balance to enhance human health. This ties into environmental regulations, the Clean Air Act, the Clean Water Act, and there are many other benefits, biodiversity, impacts on neighborhoods and crime. So understanding the structure can lead to better designs, to enhancing human health and well-being in cities by understanding the relationships between structure and function. What we do know nationally are the numbers shown in this slide. We've estimated national carbon sequestration by plants, air pollution removal, avoided emissions from power plants, and avoided energy use. Totals up annually to about $21 billion in that 3.6% land base, or about $590 per acre of tree cover in urban areas. And that's just the 4 that we know about. There are many others in the previous slides I talked about. We don't have quantification of values, but they do exist. So we're talking minimally about $20 billion annually produced by the urban forest. And we know this because we've assessed urban forests and we've assessed canopy cover, but there's huge gaps in the data. Lastly, what's most important probably here is urban forest, like any forest, is not static. Tree cover in cities is changing. What Eric and I looked at also, another study is looking at paired image analysis in cities across the United States. We looked at 20 cities specifically from about a 5-year period around the year 2000 to around the year 2005 to look at is tree cover going up and down. We also did this nationally, and Eric and our crew are working on looking at change analysis from 2010 to 2015 right now also to see if these trends are still holding. What we found, this is the graphic here, you can see the 20 cities along the bottom. The dark green graphic is what it was in the first year of the analysis, so in Albuquerque that year was 2006. The second year was 2009. We found 17 of the 20 cities had statistically significant declines in canopy cover in that approximately 5-year period. One city had an increase, and that was actually Syracuse. That was due to a lot of natural regeneration occurring and a storm that opened up a lot of space. So for the most part, canopy cover is declining in that period from around 2000 to 2005. And nationally, we estimate about 20,000 acres of canopy cover lost per year in urban areas, and about 4 million trees. Whether that trend is still holding, we shall see. Again, we're analyzing 2010 to 2015. My guess is not going to consistently go down. It's going to cycle through time. We might have just hit a downward period, or maybe we're in a long-term downward trend. We'll know that in the next year or so. So what are the things we have to be concerned about? Why do we have to have assessments? Because the environment is changing. These are my top 4 major drivers for change in urban forest, in urban areas. One we already talked about is development. People develop land, and developing land, they put impervious surfaces down and tend, depending on where they are, either take forests out if you're in forested regions or actually add forests in if you're in grassland or desert regions. So we are constantly changing the environment through development, and as we can see, we're going to have more of this, as I showed earlier, in the coming years as urban land expands. What are the other top changes that we have to deal with? Climate change is going to be a big one, altering species composition through gradual changes in temperatures, but probably through more extreme changes of massive, intense storm events, intense periods of drought, intense precipitation events are going to alter the urban forest and species composition. And we need to understand that so we can help design and have healthy forests into the future. Third on my list is insects and diseases. This is emerald ash borer. There are many others, Asian longhorn beetle, oak decline, 1,000 cankers disease. Many diseases coming that are going to change the structure of our forest over the coming years, and we need to understand that how it's happening through time, through having monitoring data. And lastly, it's invasive species, my top 4. This will actually enhance canopy cover, but maybe in a different way, and have either positive or negative benefits to the forest by altering biodiversity, but providing other services. So the environment is changing, and in order to understand how it is changing, we have to understand what we have. So with that, that's a quick summary of where we're at. I think I have time, like 3 minutes for questions here, if there are any.
Yes. So first up is, do we have any idea if or how the urbanized areas of the future will be different than they are now?
Oh, wow, if I knew that, I'd be a millionaire. They'll probably be very similar. I think technology, as technology changes, you are going to have some implications, particularly if we have changes in transportation technology, energy efficiencies. I'm sure there will be changes. I don't know exactly what they'll be. It would probably, if we make smarter designs, we might have different designs in how we design our cities, how people are compacted together or spread out, and how we do transportations. I don't know exactly how that's going to be, but I'm sure it will be somewhat different than it is today. But we tend to follow patterns of history. So unless there's a major technological change, it'll probably be somewhat similar to what it is today.
So, David, how does the assessment account for climate change? One of the viewers says the assessment does not account for climate change. In 60 years, most of urban Florida and Louisiana will be abandoned.
Or underwater. It does. Well, actually, Eric and I have done some, as part of the RPA process, have done some climate change projections in a different report of how cover is likely going to change. Some areas it goes up, some areas it goes down. We are working on that in iTree to try to look at climate change issues, looking at issues of coastal flooding, looking at issues of temperature change and how that influences the forest. So the current assessments forward of urbanization does not assume that it uses the pattern of the last 20 years. So that will not be picked up in the next 50-year pattern that we've shown. Economic booms or crashes are also going to be influence how urbanization develops, as will technology. So again, it's just using past projections to go forward.
Lou Shepard wants to know, he says, I would like to see the data source for the prediction. Is there any way people can see the data source for your predictions?
Yeah, well, the original predictions were published in Journal of Forestry. Eric and I are publishing the new predictions, and we can show, yeah, you have to contact me. My email's down there.
Okay. Is urban tree longevity declining? If so, how do we change that?
We need monitoring data to know, and it's going to be hard to say because a lot of longevity studies in urban areas are anecdotal. There are still some very old trees in there. My guess, and this is just a guess, given climate change and insect and diseases and all the forces that are going on there, is probably going down. On the other side, people water trees. There's less competition for many trees in urban areas, and so there's less competition for light and water. Some trees can do fairly well, but there are a lot of impacts that can influence that. We really don't know that answer because we don't know how long they lived in the past, and we need monitoring data to see how long they're going to live into the future. So this is why urban FIA becomes very important, because they are starting to monitor long-term in many of our cities, and we'll be able to answer some of those questions.
Okay, we have another question here. Are your values for benefits of urban forest also include those stands that are truly timber tracts that are in urban areas?
The answer to that is yes. It's all trees within the urban area. So we picked up what you consider to be stands of trees, backyard trees. Everything's considered within that.
Given the declining cost of satellite data, what will it take to get forestry satellite data for the entire U.S.? Does the U.S. Forest Service have any ambitions in this regard?
Boy, I'm probably not the person to answer that. I was just talking to Grant Domke, and the Forest Service is doing things with satellite, as is USGS. There are people doing satellite data. National Land Cover Data has tree cover maps. Tend to be fairly coarse or rough at doing tree cover, particularly in urban areas, because urban areas are mixed phenomena. With the advent of LIDAR, tree cover assessments are becoming much more accurate. So my guess is we will have better maps, cheaper maps in the coming years, and there are people working on that both within our agency and outside the agency, but there are still some limitations to doing so.
Okay, last question here before we move on to the next presenter. A lot of urban areas have old-growth trees that have been protected for years. As mortality creeps in, how do we plan to replant, replace with new trees?
Oh boy, how do we plan to plant? That's a local question. That's why we're trying to get information out through iTree and through the FIA data so people understand the values of these trees, particularly old trees, because they have huge values, both ecologically and sociologically to urban systems. So by understanding that, you've got to start today to start planting, because it takes, to get a 100-year tree, it takes 100 years. So we need to start understanding and protecting those old growth stands, but also trying to plant for the futures. And that becomes at the local scale. This is why the inventory becomes very important to understanding, so people can understand the value of the resource that they have, so they can do smart planning into the coming years.
Okay, thank you. We'll move on to the next presenter, and the questions that we miss, I've captured those, and we'll ask them at the end if there's still time.
Okay, this is Hobie Perry. I hope you all can hear me okay.
We can.
I assume that me? Okay, great. My colleague Greg Lickness and I both work for the Forest Inventory Program as well, and we'd like to talk about many of the questions that have been raised. Frankly, as part of this conversation, reinforce some of the themes, and hopefully we can address some of those issues by talking about developing a monitoring framework for forests, agricultural and urban forests across the United States. The goal really for us, if I were to sum it all up, is really just to emphasize this sense that forest inventory is always changing. And one of the big changes underway right now is trying to extend the inventory into urban and agricultural landscapes. So that's an important thing to bear in mind, is that it's not a static program, but continuous change, and now we're attempting to move into these landscapes that we've neglected for a long time. It is a national program, and we are trying to take these same sort of objectives to the agricultural and urban landscape. So trying to get an idea of the area of land, the volume, growth, and removal of the various resources in those landscapes, as well as the health and condition of the urban and agricultural forest. So the quick question I guess I would start with, just we've been on the phone for a while now, get your brains thinking a little bit, is I'd be curious to know which of these criteria is not part of FIA's definition of forest land. Stand area, stand width, land use, land cover, or none. All of these are actually part of FIA's definition. So I'll give you a moment there to try that poll. Remember, the polling is under your name in the participant window. Give folks a few minutes here. Well, not a few minutes, but some time.
Remember, to participate in the poll, look under your name in the participant window, and you will see the fourth icon on the right in which you can choose your answer.
Okay, it looks like people are slowing down. So most folks are saying none, that all these are part of the definition. Well, I'm going to show you the definition here. The traditional focus was on forest land, and forest land was defined by an area of land that was at least a minimum width, and that was under a particular land use. The goal there was that trees would grow to a certain cover over time, but having any particular persistent tree cover at that moment is not part of the definition of forest land. So for example, you could have a treed landscape, harvest those trees. We would still consider that forest land as long as trees were presumed to be coming back to that landscape into the future. So the correct answer for those of you keeping score at home was land cover at that particular moment. Now what does that mean? If we're looking at these landscapes using that kind of a definition, a lot of trees are falling through the gap. Those landscapes where the group of trees is not an acre in size. Traditionally, this notion of it being in the urban landscape, that's a different land use, so those weren't counted, or in these agricultural landscapes where the treed features were not 120 feet wide. So there's a recognition that we're missing a significant resource across the landscape. And just to summarize what we've seen from the presenters already, I think by now it's clear that all of these trees have value, whether they're sequestering carbon or increasing crop yields or providing shade on your home. Basically, handy trees should be tally trees. So that's what we're trying to do here, is modify the inventory to make sure that all trees are important and are counted in a truly comprehensive picture across the landscape. Relatedly, since we are the part of the organization that contributes the official forest carbon estimates to international collaborators, it's important to count these resources because land use change is one of the most significant accounts in the carbon inventory. So tracking those trees in forest land versus agricultural land versus settlements is an important part of making sure for attribution purposes we're accounting for all of the carbon across the landscape. So the goal then really is to try to leverage the entire network of plots across the country that FIA has. If you look in the left-hand panel here, you're looking at the thousands of plots that are in traditional forest land. If you look in the right-hand panel, you'll see That's the total plot network focusing on those plots that are in non-forest. The blue plots would be in, let's say, grasslands and rangelands. The pale green plots on the right-hand side would be in agriculture, and the red plots would be in urban lands. So essentially we want to use the full network of plots to try to generate a more comprehensive picture of the treed resource of the United States. Now as we move forward, an effective system is going to meet several criteria to really help us move in the direction we're hoping to go. I don't want to go through all of these, read them all for you, but I think it should be clear that presumably things like statistical validity, that's a very important factor, a high value criteria for us, that the inventory system is statistically valid. You look at number 5, a public database, right? We don't want to just collect this information for ourselves. This resource should be available, the information resource should be available for folks like yourselves who are making management decisions. Let's look at number 8, an interaction with a user community. Some sort of collaboration so that as we're collecting information, we're collecting the kinds of information that folks need to make decisions, not just collecting information because we happen to think it's interesting. So just to think then, where are we right now with Urban FIA? Dave hinted at this. The Austin Urban Forest Report is out, and that's available on Tree Search right now, but let's talk about, in general terms, what it is we're trying to do with the Urban FIA program. And then my colleague Greg is going to talk about the work we've got going on in agricultural landscapes. Dave showed a map like this. This is from late last year, the 2015 implementation status, where we've identified urban areas as target candidates for adoption of an urban FIA program. Those with all the smiley faces are currently active, and then we've got additionals that are coming online. But beyond that, what does it actually look like when we try to establish an urban FIA program? So let's step through Maryland as an example, just to give you a sense of how we lay out the plot design and how we go from the traditional one plot for every 6,000 acres, which probably is going to be too coarse to collect good information, into the sort of inventory that actually can provide useful estimates at the scale we're interested in. So we start with intersecting the plot network with the census boundaries provided by, the urban boundaries provided by the Census Bureau. And then we can see here we're focused on, let's say, the area in yellow, which is the core area that we're focused on there. And then as we zoom in, we can see we've got only a small number of plots. And ideally what we're trying to do is get around 200 plots in order to have a stable estimate. So what we end up doing then is intensifying that part of the landscape that we have particular interest in order to reach that at least 200 FIA plots. So we go through a standard intensification process in order to distribute those randomly across the landscape. So we've got a relatively coarse sample in the external part of the urban area that we're curious about but not necessarily focused on, and then intensifying the plots in the heart of the city. And that's really based upon historic iTree sampling and U4 reporting, trying to get the sorts of information, the density of information in order to populate the models that Dave and his group is building for iTree Eco, and all of the ancillary products there. Another thing we've had to do, though, is simplify our plot design. For those of you that are familiar with the FI program, you may recognize the standard 4 subplot plot design, and in an urban landscape that's just too onerous to implement. We'd have to be contacting owners, and in order to maintain efficiency, what was done was to take effectively the same area and turn it into one big plot that gets dropped over the central subplot. So just to emphasize, this is still based upon the FIA plot network. We've intensified it, and then where plot center falls, we've now placed one single large plot as opposed to our traditional 4 subplots. And then as we go into that plot design, we've now then moved the microplots into there where we're going to do things like major saplings and so forth. So the main plot is for sampling of trees, and then the microplots are for sampling saplings. Sorry, I'm tripping over my tongue there. And as I mentioned, this data is now being collected across the landscape in several urban areas across the country. Dave already mentioned that the Austin report is out. That's available at Tree Search. The Houston report is being written. I want to emphasize that right now our folks are building the companion database for the distribution to folks like yourselves, as well as the sorts of tools you might be familiar with that we've had in the past, things like eValidator and so forth, as well as the Data Mart. Those companion materials are all being prepared right now, again with the view towards collecting inventory data as well as distributing it to the users like yourselves who have a need for authoritative content. With that, I'll turn it over to my colleague Greg, who's going to talk about the sorts of activities we have going on in agricultural landscapes.
All right, thank you, Hobie. So now we transition from urban inventory to inventory monitoring in agricultural landscapes, and I'll say up front that the inventory in these areas is not as well developed as the urban areas, as you'll see. Yet, as been discussed earlier in the webinar, these trees do provide critically important services. One contrast between ag and urban lands is that of aerial extent. So consider again this map on the lower right that Hobie showed just a little bit earlier. While the urban areas shown in red are complex environments with many, many landowners, they represent a fraction of the nation's land area. And I think Dave said it was 3.6% in the last census. So the expanse shown in blue and green, the croplands and rangelands and grasslands of the U.S., it's a vast expense, and it represents a significant logistical and financial challenge to develop an effective inventory and monitoring program beyond what we do right now for forest land. So in this portion of the webinar, I'll talk about some of our current efforts to address these challenges. Remote sensing represents one tool we can use to efficiently monitor large areas. It provides context by answering basic questions about tree resources, such as how much is on the landscape, what is it doing, and how is it changing. We're fortunate in the United States to have access to many sources of high-resolution data sources that can help us observe these smaller clusters of trees. Our National Forest Inventory makes extensive use of aerial photography from the National Agricultural Imagery Program, NAEP, and we have a rapidly growing collection of LiDAR data sets available as well. Remote sensing does have limitations, but we can work in tandem with field-based observations, but it can work in tandem both to enhance efficiency and to enrich the type of information collected. I'm going to share a little bit about a new remote sensing effort within the U.S. Forest Service termed the Trees Outside Forest Image-Based Inventory, or Team TOFI. It's a partnership between the Northern Research Station and the National Agroforestry Center. Our mission is to develop efficient methods for mapping tree cover focused on ag lands, and to use that information to help infer the function of trees on the land. By building from a data source like NAEP aerial photography with a proven track record of repeated data collection, we also hope to monitor trends over time. In short, we are using remote sensing to answer the how much, what is it doing, and how is it changing for trees in ag lands. This is a simplified overview of our mapping process. We start with aerial photography from the NAEP program. We use a process called image segmentation to divide that image into similar objects, and then we assign a land cover class to each object. This is an example of what is produced from the process. Michelle showed this county level map of tree cover in Antelope County, Nebraska a little bit earlier. This is one of the original counties in the Prairie States Forestry Project. So you can see there's a relatively high density of windbreaks throughout the county and a pretty significant riparian area, albeit with pretty narrow tree features surrounding the riparian corridor. Because this map is a geospatial data set and we know the location of the tree features, we can combine in many ways with other data sources such as soils data or wind information to examine things like erosion potential. We can also aggregate up to a county level and examine statistics and draw comparisons between other counties. Here we show that if you consider tree cover rather than forest land, there's 3 times as much tree covered land in the county. We can also compare to other data sets, such as the National Land Cover Database, which is based on lower resolution satellite imagery. So you can see here the estimates from something like NLCD relative to the high resolution map miss some of those trees that occur in these narrow windbreaks. We can also start to infer the function of these trees on the landscape from their context and their shape. In this example, from a small study area, we have identified trees that are acting as either field or farmstead windbreaks and can report a linear measure, and in this case miles. Here we examine the directional orientation of each windbreak and see that north-south is the most common arrangement in the study area. This type of information can be paired with climate data, winds climatology, and knowledge about crop rotation schedules to determine if the windbreaks are protecting fields when crops have been removed late in a growing season. So here again we revisit the slide looking at change in tree cover between 2009 and 2012. So that's what these maps will give us. We're laying down a baseline in Nebraska for 2009, and it makes picking out these changes rather easy. So we have a lot of anecdotes telling us that windbreaks are being removed from the landscape, and now we can start to put some data behind those anecdotes. As I mentioned, ag lands cover a large expanse in the United States, and this presents a technical challenge. Using Nebraska as an example, there are 200 billion pixels in the MAPE dataset for each year of imagery available. We've been working hard to develop methods to overcome these challenges. We've developed a workflow that we're just now starting to share with partners at state agencies and universities. We provide tools and training that allow students to implement our mapping procedure. By partnering with local agencies, we put the data in closer proximity to their user base, and we'll be multiplying what we can accomplish alone. We will continue to build out partnerships and hope to cover a majority of the ag lands in the central United States. Eventually, by raising awareness of the dynamic tree resource in ag lands using these map products, we hope to increase support for field-based observations as well. And with that, both Hobie and I can take some questions about inventory monitoring.
Okay, so the first question that has come in is, what is the budget for this program?
That's a good question. Right now, to my understanding, this is something that the National FIA program has decided to implement as part of its traditional budget. So a way that this is frankly going on is by finding efficiencies in other parts of the FIA program, for example, moving to single-person plots in remeasurement in rural landscapes. That's provided us the kinds of efficiencies and savings that we need in order to try to implement the urban program. I could definitely dig around and try to get a number for you to estimate how much is actually being spent. If I was given the name of the person, I'd be happy to try to track that down.
Okay, we'll let him respond back. Or maybe if he could email you, maybe a better solution.
Sure, that'd be fine.
So if you want to type your email into the chat window, he'll be able to pick it up there.
I will do so. Yep.
Okay, so the next question is, do you think conventional or urban FIA sampling techniques would be transferable to ag lands? What would be involved?
I'm going to leave that one for you, Greg.
Yeah, I think there's components of the FI inventory process that would transfer. So, Hobie walked through that example where we use the existing plot network and then we intensify it. But then they had to make modifications of the actual plot design on the ground to fit the urban environment a little better. I think we would see some sort of similar change to the plot design to accommodate the agricultural windbreaks and that type of tree arrangement. The cluster plot that's used in a forested environment may not make the most sense when your features are relatively narrow. But the rest of, programmatically, we've got the plot network, we have the processing routines and database and public-facing information and publication, all of that infrastructure, I think, transfers nicely to ag lands, but there would be some technical details about data collection that would change.
Okay, the last question before we move on, are there any concerns about comparing data collected with more precise modern technology with those data collected with older technology?
Yeah, that's always a concern. I mean, you could back up and say, is there any concern about comparing estimates from many years ago with estimates of today in the rural forest, because some of our definitions change, some of the design of the plots has changed and so forth. So that's always a concern, and we do our best to try to be transparent in identifying the same pieces of information collected in the past and comparing that to identical pieces today. So that may restrict some of the kinds of analyses that can be done, but particularly when we're looking at trend analyses, we put a real premium on trying to make sure that we're comparing apples to apples and be very clearly about stating any assumptions that we're making with changing protocols and so forth.
Okay. And with that, we'll move on. I believe.
Okay, I guess it's my turn to come back. I hope you all can hear me. Very good. I suspect you can. All right. It's my job right now to just wrap up the presentation and go into the first slide here. And the main point with this slide, it's got a lot of text in it, but the point we wanted to bring up is the fact that in these presentations and in the report in general, we did not delve into actual sustainability assessment, but we did use the criteria and indicators, those of the Montreal process, somewhat as a guide, but really that application was not very thorough either, and it would be disappointing to those who were looking for a thoroughgoing sustainability assessment. The only point I want to make with this slide, though, is when you use something like an explicit set of criteria and indicators to look at some of these questions, and we provide this in the final chapter, you start digging down very quickly to specific indicators, specific questions, and asking yourself the details. So often these sort of discussions, like what we're talking about right now, and when you're talking about sustainability in general, dwell at the conceptual level, and they don't get down to actual measurements and actual indicators. And that is one of the benefits of having an explicit indicator set, is it does push you down to actually asking yourself what sort of things would be involved in trying to measure some of this stuff. Okay, and this would be another example. This one was linked to recent iTree developments. It has to do with ecosystem services. It's also one of the Montreal process indicators, and yet it has been adapted considerably for this. And we won't spend time looking at the text here. Okay, so to finally come up with the conclusions, the one thing we can say is advances in FIA, including urban FIA, point to feasibility for inventory of this and the need for a wall-to-wall inventory covering the agricultural forests as well. You'll notice throughout this presentation that while we talk about integrating these resources, and even at the beginning at that poll, the high degree of interest was from people who wanted to see forests as a unifying concept between agriculture and urban lands, and probably also conventional forests. We weren't really able to do that. We're still binned up into our different areas of expertise. And I think that was very clear. And one of the reasons why is we don't have the information base that allows us to speak across these different land uses and land types. So, but at the same time, we're seeing advances that are allowing us to get closer and closer to this objective. And so hopefully we can move to looking at agricultural forests in really all lands. And such an inventory would provide a foundation for true landscape scale management, the integration of disciplines and picking across wildland, agricultural, and urban land uses, and a way to assess the status and sustainability of all U.S. forests. And that really is the goal of the sustainability assessment program that I work in. And so finally, we're to the end of the presentation, and I believe we're at 3:30 sharp. I don't know if if Bob can give us time for additional questions. if there are. But here's where the report is available. And if you want a hard copy version, please email me at the address given below. And I'll turn it back to you.
Thanks, Guy. We can hang on for a minute or two to answer questions, but before we go into further questions, for those that we did say the webinar was an hour and a half, so I'm going to push out to you the link that will take you to the final survey and the post questions that you need to complete if you're looking for continuing education credits. So what will happen is it's going to launch your browser. And so just be patient with it. Give it a minute. There's 100 of us online or so, and so it's trying to launch all of our browsers at once. So just bear with it, and that will give you a chance to complete that satisfaction survey and stuff. It looks like everything's working. My browser came up for me on my computer with the survey. So while it's doing that, feel free to take time to complete the survey while we go through any other questions. There was one question for Dave Nowick that didn't get answered, so if we could go back to that one, I'd like the participant to be able to hear that response. And Dave, that question is, there is increasing interest in urban agroforestry, i.e. urban orchards, food forests, and using edible perennial species in urban areas as another tangible benefit of urban forests. What are thoughts on how this might play into future trends of canopy cover? Is there a way to use the interest to increase canopy cover?
That's a good question. Yeah, the interest could be to increase canopy cover. Whether cover will go up or down, again, we'll need the monitoring data, because you could increase agricultural crops in urban areas but lose other crops, like we're going to be losing ash trees in many areas. So the net balance is tough to predict, because there's many pluses and minuses that will be going on. I think it's a good question. When we talk about urban agriculture, though, one of the questions we've got to worry about is depending about what's in the soils and what the plants and fruits might pick up, because the soils are often contaminated in urban areas. But there is pushes in many cities for urban agriculture, for crop production, and for orchard production. So I can't predict which way it's going to go. I think it's an interesting question. When we talked about bringing iTree to FAO internationally, one of the things they were very interested in third world countries is food production. So we're starting to look at that in iTree, which trees produce crops that can be edible. But it's going to take a societal change, because a lot of the nurseries drive what species are being planted, so the fruit trees would have to be available. So future will tell.
Okay, and with that, we'll open it up. Let me just make sure we didn't miss any other questions. I think we have. Them all. Oh no, here was one. So the question was from Peter Yang, who was wondering which data set, example NDVI, did you use for forest health?
This is Greg. Is that question specific?
I think it's for hobby, maybe.
Okay.
It was during their presentation.
Sorry, I was on mute. When I talk about forest health and our assessments of that, the overwhelming amount of work that we're doing in FIA is assessing health in the stands. So they're making assessments of any faults in the trees, any fungal, any sorts of problems that we've got with diseases or insect infestations, crown dieback, and so forth. So the FIA data is all based upon field observations. That being said, my colleagues, Greg included, have done some work using aerial survey information from the FHM program, as well as satellite data, different spectral responses, different satellites, and so forth, to try to understand linkages and broader landscape scale patterns of forest health. I guess I'd pause and see if anyone else, Greg, for example, had anything they wanted to add to that.
No, I think that's a good assessment. We use a variety of tools depending on exactly what we're looking at. In terms of the maps of the ag lands that I showed, we weren't specifically trying to detect health concerns, but we do make extensive use of NDVI when we do that mapping work.
Okay, what do you say, Bob? Do you think we should call it quits? Oh, here's another one.
So the other question is, I am wondering which data, MODIS-based or Landsat-based?
Sure, I'll try to address that. We've got several colleagues who are looking at attributing pixels with plot information, and they were using MODIS data because the MODIS data offered...
I don't know.
Oh, again, feedback somewhere. The MODIS data offered greater return rates over the plot, so they were able to develop phenology curves out of the spectral responses, which turned out to be very effective prediction tools. But now, given the people's interest in higher spatial resolution, that same strategy, scientific approach to linking plots to pixels is now moving to Landsat.
But with the younger kids, like this 6-7-year-old age group,
Excuse me, folks.
like
Somebody's mic is on. Talking about kids? Okay, thank you. I think we are to the end of our webinar today. And thanks to our presenters for taking their time out to put together a very informative webinar. We do appreciate it. It is recorded and will be available on demand in a few days on the Forestry and Natural Resource webinar portal. And with that, Guy, I'll turn it over to you if you got any last words.
No, I don't have any last words except I apologize for the poor audio on my end, and thank you everyone for coming.